Hello and welcome. Today I'm here to talk about the scientific view of cameras. So why a camera is not only useful for keeping your memory snapshots, but why they are also extremely powerful measurement devices. Let's start with a small experiment. It might have happened to you before that you wanted to read something but it was written with too small characters and you couldn't read it. Or there was something in the very far distance that got blurry in your vision, so you couldn't see exactly clearly what's going on there. Now in these kind of situations, a very good trick is to form a small circle with your palm and put it right in front of your eyes and look through this small hole. It actually gets your vision very, very clear and you will be able to read things you couldn't read before. What you actually did in this situation is you went back to the very ancient model of a camera obscura. A camera obscura looks like this. It's nothing more but a box with a small hole on it. This is the same kind of hole that you did with your palm when you looked through it. This is where the light enters into the box. Inside the box, there is only a simple photosensitive paper in the back of the box, and the picture gets projected into this point. Now the important point is that this small hole makes a one-to-one mapping between the scene points and the points on the photosensitive paper. Now, in order to be able to measure things in the scene, so be able to reconstruct it with proper metrics of the scene, we actually need to calibrate how this box looks like. And as you see, there is pretty much only one parameter in this box that you can actually calibrate, you can actually find out to be able to measure, which is the distance between the photosensitive paper and the hole. So this distance, this is the only fundamental distance that you need to find out in case of this camera model. This we call the focal length. Obviously, there are many small, super sophisticated cameras out there. Interestingly, when it comes to reconstructing the 3D screen or just to measure distances in the 3D scene, engineers always go back to this model of a camera, and they massage the image so that it actually fits to the model of the camera obscura. And hence, once you would like to calibrate the camera, so that kind of prepare it to measurement, you actually need to find a few parameters that maps the camera's image into a camera obscura, and then you only need to find out the distance between the hole and the photosensitive paper. Let me give you a very simple example how you can measure distances with a camera obscura model. Imagine you have 2 points in the scene, the 2 red dots. They are going into the camera obscura. These are the light rays. This is one, this is the other. And as you see, we actually get 2 similar triangles. Here we got this triangle here, and we got the triangle inside the box. And these triangles are obviously similar if these points are equally far from the camera's focal point. Now, if you know the distance between the distance of these points from the camera, and you kind of read the distance on the image, which is something that you can do with computer vision techniques, then you will be able to tell the distance between these 2 points in reality. This is how 3D reconstruction and measurements in the 3D scene works. In the coming videos, I will show the mathematical background, hopefully in an understandable manner, on how to measure distances between points in the scene, or how to calibrate your camera, no matter how complex camera lens system you might have. Thanks for your attention.